Hello and welcome to this series of show and tell videos. My name is Jorge Amodio and I am with the San Antonio Museum of Science and Technology. I'm recording this while we are going through some challenging times with the COVID-19 pandemic. While the museum is closed, we are still active, working to fulfill our mission to inspire minds to innovate through science, technology, engineering, and math. I've been involved with technology since a very young age. My career took me from electronics, computer science, networking, global scale networking, and electronic system designs for human-machine interfaces and Internet of Things. Lately, working at the San Antonio Museum of Science and Technology at Port San Antonio to share some of the expertise and knowledge I gathered through my professional career. So I will be talking about some of the technologies involved with many of the items and artifacts that we have at the museum or that are related to the activities that we perform at the museum. So to give you an insight of what we do and what you can expect when we get the opportunity to open the doors and welcome you back to our museum hall. We have so many cool things to show you and many stories to tell. So hopefully this is gonna be over very soon. I hope you enjoyed this video and stay safe. On this video we are gonna talk about relay computers. So I put together a presentation and a few video clips to share with you. So let me get things right here. Okay, there we go. Before we get on the computers, let's talk a little bit about history. What started all this, need for computers and how to facilitate, making calculations. From the early days, from the 2nd century Chinese abacus, it's called the sampan, or 1st century Roman abacus, we were always trying to find some mechanical aid, to facilitate making, mathematical calculations, doing some basic operations. And obviously when we were doing this by hand, we didn't repeat, the same calculation for some functions. If you wanted to calculate the square root of 2, we did it once and then we wrote, what was the number of the result of that operation in a table. So that got formalized in the 1544 more or less, and we created tables. In 1614 John Napier wrote a book that was called the Description of the Wonderful Rule of Logarithms, and I'm checking on my notes here. And what we did is we found ways to solve many mathematical equations using logarithms. So we have a book with a table of the logarithms where one of the columns you have an integer number and then the other column was the result for the logarithm or maybe other mathematical function like trigonometric functions for that number. So we started using this as a tool to help us facilitate calculation. But it still was, tedious because we had to go get the number, go write the number in a piece of paper, and go back, to doing everything by hand. By using logarithms, that made things simpler to perform scientific calculations, one invention was the slide rule, and that was invented by Reverend William Aubrey in the 17th century. And really, they look, we have on the pictures, I have one, to here show you. They are called slide rules because they are different parts of, the rule that slide, even the cursor. And each of these lines that you see here, they represent, a different mathematical function. So by sliding the parts of the slide rule, we were able to perform, with some precision, some complex mathematical calculations. William Alfred is also famous because this is the mathematician that invented the X sign for multiplication. We have a very cool, slide rule at the museum, which is obviously not for use, but just for showing. And we have other artifacts, also like an abacus and more complex, systems. Still, mostly most of the operation was done by hand, and then we started working on calculators, things where by mechanical means we were able to perform a calculation, like this mechanical calculator from Burroughs that was called the hand and crank. So you had to set the numbers there, set the operation, and then move the crank to perform. And it was it had a printer, so it was called the adding listing machine. It was patented by William Burroughs in 1888 and produced by his company, Burroughs, Corporation, in Detroit, Michigan in the 1900s. A similar device, like this one, was based on the patent of Frank Baldwin from 1873 and was produced by the Monroe Calculating Company in, New Jersey. And, funny thing is that still, the Monroe Company is in business, providing, tools and devices for business, for, the operations. Why all these mechanical, aids? From the early days, mathematicians and scientists were trying to solve complex mathematical equations. And I will not get on the detail and spend many hours trying to explain this, but we needed to solve complex equations with multiple variables, multiple equations, differential equations like what we are showing here. So it required a lot of hand calculations. So all these mathematicians and scientists were always looking on a way how to automate, how to make it easier to perform all these calculations. And one of them was Charles Babbage. We consider him to be sort of a father of the computer because he is the one that in 1837 became with the idea on how to put, a general, purpose computer, all mechanical, that we call the analytical engine. The problem is that he was ahead of the time. He was able to put all the design on paper, but the manufacturing techniques and processes of the day didn't let him build the machine at that time, didn't let him build the analytical engine. It was built later, and it proved that he was on the right track to provide a device to facilitate mathematical calculations, particularly to solve differential equations. Another big step forward, and we will talk more when we talk about digital or electronic computers, in a different video, was the use of logic functions and Boolean algebra. Boolean algebra was established, by George Boole in his book of, Analysis of Logic of 1847. And I will not get much into details, just give you a basic concept that, this is a binary system, so there are only two numbers, that is 0 and 1, and you are going to see how this is related to relays and switches, because these are two states only. It's like on and off, true and false. So what George Boole put together in a form of analysis of logic and the algebraic logic was a series of functions, where for example the not function was, if we have a variable a that is on 0, the output of the not function is going to be 1. If we have a different logical function that we call AND, the output is going to be 1 only if both inputs are 1, A and B, only 1. And OR is going to be 1 if any of the inputs are 1. And we can complicate things more, we call it NAND, when we combine an AND logic function with the NOT logic functions, is not AND. and you will see that, is 1 when only, any of these are 0 or 1, but not both. So it's only 0 when both are 1. So this is the NOT of the AND function. And why I'm talking about this representation is what we call logic gates. And this will have much more sense when we talk about this on digital computers. And I told you, these are two states, 0 and 1, on or off. So, and this is the connection, with switches. So what is a switch? I will show you later, how they work and how we perform logical functions with switches. A switch is a mechanical device that have, 2 or more contacts. There's an actuator, a lever, it's a mechanical thing that moves, the contact between the terminals, and that's how you close a circuit. This is what we call a circuit, and this is the symbol for a switch. And for example, we were talking about the AND gate. This is how you can put together an AND gate with 2 switches. This light is gonna be on only when the 2 switches are closed. So we get the battery, current flowing, and the switch is gonna perform the AND function. The OR function, instead of having the switches connected in what we call series, we connect them in parallel. So this lamp is gonna go on only when any of these 2 or both are on. So you see, we close A, the current is gonna flow through, the switch to the lamp, or if we close B, or we close both, it's gonna flow through both. So that's the OR function. And we can make this more complex. And that's how the Boolean logic, and binary algebra starts, because we can start putting together complex functions, like doing a binary adder. So this is very simple because it's only 2 variables, again 2 states, 0 and 1. And if we want to add, the value of A to B, we just build this circuit using logic, and then this is the sum. And what happens, it's only 1 digit. So if we get 1 plus 1 in binary, that means 1 0. So where is the 1? That's the carry out digit. It's when you are doing addition that you go column by column, and then you need to move, the 1 that is left over. If you go over 9, you put the 1 on the next column. In binary, same thing. That's called the carry out. And we can get more complex with gates. We can have a full arithmetic logic unit made with gates. This is a 4-bit arithmetic logic unit. And talking about digital computers, these kind of things were built inside an integrated circuit, what we call a chip. So you were able in the 70s to buy this chip and put it together with other chips, and that's how you build computers. So talking about switches, let's go now and look at how they work. And also we are going to see the relationship with switches and relays. Okay, let's talk about switches. As we mentioned before, a switch is an electrical component that has metal contacts inside, and the mechanical means to close those contacts in a way that will let electricity flow, like this one. This is the typical switch you have in your home, where you move the actuator or lever and you close these 2 contacts, letting electricity flow, and you turn on or off the light. A similar type of this switch that you may find on pieces of equipment like computers is this one. You get the lever there and the contacts. Similar type. Even this one show you which position is on or off, and here are the contacts. Similar, but this one has 3 contacts. So what happens here? When this lever is in the center position, no connection, there is no contacts connected to each other. When I move this way, these 2 get connected. When I move the other way, these other 2 get connected. A different type of switch is what we call a momentary switch or a push button, like this one. When you push that button, you close the contacts on the two sides, and you will find this like in your doorbell. Ding dong, when you push, you close the circuit and you let electricity flow. Similar type is what we call a micro switch. This one are used on equipment or other applications where you have a lever, a little push button there, and when you hit the lever, the button, goes in and close these two contacts. Imagine you have a slider that is coming here, and it hits the sensor, and you close the contact. We have all sorts of switches, even the small ones, like this one, 3 positions again. You move the slide there, and you connect one side or the other. But how all this works, we'll show you. What I have here, is my switch, and I have a battery on a proto board. These lines are connected together, so what I have here is, the battery is connected to a limiting resistor, and instead of using a light bulb, I'm using what we call an LED, light emission diode. But the circuit is not complete, it's not connected to the other side of the LED. And what we're gonna do, we're gonna add our switch here to complete the circuit and see what happens. So there's no connection yet. The switch is in the central position. I'll show you. Let's see what happens when we move the switch to the position where the contact will close, which will be this way. Oh, we have light. So what happens is that, electricity starts flowing from the battery through the switch to the LED and then going back to the battery. And that's how basically a switch works. And we mentioned that, this situation will let us work on how to design a computer, how to do Boolean algebra with switches. Let's talk now about relays. So what is a relay? A relay is a switch. It's a special type of switch that we can control with another electrical signal. We call them electromechanical switches. And they work in a similar fashion like the other switches. It has metal contacts that open or close, depending on the electrical signal that we send. There are all type of relays, sizes, models, and options, but I have one here that I removed the cover to show you how it works. We have 2 contacts here that are the control winding. Is this thing that you see in the middle there. There are many rounds of very thin copper wire that works like a temporary magnet. When we send an electrical signal between these 2 contacts, this one works like a magnet. And here what we have are the contacts of the relay. It's like a switch where you have a center position that is connected to this way and this other 2 sides. If nothing is being sent to the relay, there's no electricity going to this, these 2 are connected. This is what we call normally closed. Now, if we send an electrical signal here, this one is going to act like a magnet, and it's going to attract this armature, and it's going to bring the contact that is on the middle to the other side. See there, those contacts? When the winding is activated, it's going to move this way. Now we are closing this one and this one. And that's how, an electromechanical switch works, by sending a control signal and moving, the contacts from one side to another. Imagine, hundreds of these is how we can build a relay computer. And I will show you a little bit how they work. Let's see a relay working. What I have here is a bigger proto board, and instead of a battery, I have a power supply. And the relay, I have one of the contacts is connected to a green light, and the other one is connected to a red light, and the control winding is connected to this momentary push button. So let me turn on power and see what happens. So you see the green light is connected to the normally closed, so it goes on. And when I press the momentary push button, the other, light goes on, and you can see the contacts on the relay that are moving in there. See how they move to one side to the other. Another thing that I have here is that, I have a pulse generator in my lab, and I'm going to control the relay by a pulse signal from that generator, and I'm going to do it through this transistor. So let's see what happens. So that's just 1 cycle per second. You see how the contacts move? And we say, this relay is just a switch that we can control. So if it's a switch, can we control a relay with a relay? Yes, of course. So look what I have here. I have a second relay that is controlling the blue light in here. This one still has the cover, but you can see how the relay moves, and it's being controlled by the contacts of the other relay. And these are the building blocks of a relay computer. And if I increase the speed, you can see what happens. So that's how relays work, and how we can put hundreds of them together to make a relay computer. So we saw how the relays work. So let's go and talk about how relay computers started. In 1936, a German engineer, his name was Konrad Zuse, started putting together one of the earliest electromechanical computers using mechanical parts and switches, like the relays. So he started building this in 1936. It took him, 2 years to complete, the first version, and it had more than 30,000 mechanical parts. It was called the C1 relay computer. And since we were about to get started on World War II, things didn't went very well, and he was not able, to get funding or, the proper parts to keep, developing this technology. And he started building in the living room of his family house. And he was able to rebuild this machine later, in 1987, and now is on exhibition in the Berlin Museum of Technology. This is a replica of the original C1 computer that, it worked. So he kept working, during the war, trying to, get components from where they were available. Some he made them from scratch. And he put in 1941 the C3. In 1942, he started working on the C4. And then, the C2 was destroyed on an air raid in Berlin. And during the war, he was not able to finish, completing the C4 until war was over. He was able to move it out of Berlin, and he started, completing that machine in 1950 after moving it to Switzerland. So, what about the U.S.? What happened, in the US in those times? In 1937, there was a group that were already working on a machine that were inspired on the same analytical engine that Babbage, tried to put together, many, many years ago, 100 years ago. And with cooperation from IBM, Harvard University, by, the lead of Howard Aiken, put together what we know as the Harvard Mark I, or ASCC. ASCC means Automated Sequence Control Calculator. So it was a big electromechanical calculator, like the one that Konrad Zuse put together in Germany, but this one was massive. It had 750,000 parts, and it was huge, it was heavy, but it was used for ballistic calculations for the Navy. And one of the early users was a person that was called John von Neumann. And we are going to talk about that person more when we talk about digital computers. This is another one of the people that established the foundation for modern computers. So he was one of the earliest users of the Mark I when he was working in the Manhattan Project on research for the atomic bomb. So this is the team that put together the Mark I. This is Howard Aiken, in the center. He was, from the University of Wisconsin at Madison, and he was also working on the Navy. And next to him, there is a very important person also in computer science history, which is Grace Hopper. She worked with one of the earliest, electronic computers, the ENIAC, and she is the one that put together, the final description of the COBOL programming language. So what about, modern times? There were many other, electromechanical computers that were developed over the time, but coming, to our, time frame, in 2005, a professor from Portland State University, his name is Harry Porter, he put together, inspired on the idea of Konrad Zuse's, computer, electromechanical computer. He put together a relay computer using 415 relays to show his computer science students how computers work. And it was a fully functional computer. And based on this design, years later, a group of engineers from Austin put together another computer that is called the RC3, or Relay Computer 3. And I will show you some videos and images of the RC3. So the RC3 was built by, a group of engineers that were working with the Goodwill Computer Museum, and the main designer was Phil Rice, a good friend, and still working with us at SAMSAT. After the Goodwill Computer Museum closed, they started putting together, kind of an itinerary museum that was called the Museum of Computer Culture, and in recent times they closed that operation, and now they are part of our museum, the San Antonio Museum of Science and Technology. So when they finished in 2011 to build this machine that obviously Harry Porter, that is the one that put together the Relay Computer 1, help on the design. They were showing off this machine in Austin, Texas. It has 418 relays, 421 lights. It's very impressive to see it in person. And it's working at the blazing speed of 6 cycles per second. So it takes several seconds to complete an instruction. Here we have part of the team that was working, on putting together, the relay computer and different phases on how, they started testing like I was doing before, with the protoboard, some of the parts or designs and modules of the relay computer tree. Then they started doing all the wiring and putting everything on a cabinet. Are there other relay machines? Yes, there are other people, even people that got inspired by the RC3. There's a good, fellow in England that put together now a relay computer, very advanced one, and there is even a simulator online for that computer that was inspired on the RC3 with, different type of design. So here are some videos of different relay machines. So as I mentioned, the relay computer, the RC3, has been moved to the San Antonio Museum of Science and Technology, and we have it on exhibition, and you will be able, to see it in action, still working, and it's, as you've seen in the video, it's always printing, on this dot matrix printer all the time there. So it will be, a good thing for you to see how all these lights move running a program at that blazing speed of 6 cycles per second, which, by the way, is about 6 billion times slower than your phone. So yeah, we are, the relay computers, and I hope, you got a good way, to learn about one of the, particular items that we have at SAMSAT. Well, I hope you like this video. Please like and follow our Facebook page. You can also visit our website where you will find more information. Our education team has put together many interesting classes, virtual tours. If you have any items or artifacts that you wish to donate to the museum, feel free to contact us. If you want to make a monetary contribution, you will find a link on our website, or you can contact us. And for now, thank you, and looking forward to welcome you to our preview center for the museum at Port San Antonio.